actually in the screen?
Yep, you're right in the bullseye middle. And it's recording. Don't worry.
Come on.
But you're not smiling.
Well, I'm not ready to shoot yet. Hey everyone, FG back here again. I also have the director with me who is running the second camera. You know, the director, always to be heard, never to be seen. She likes hiding behind the camera instead. So anyway, I had several people ask me that, aren't quite so familiar with wiring projects, and some people kind of look at almost like some sort of black magic that, that since electricity can't really be seen except for, well, maybe lightning strikes, it's one of those things that some people can't seem to wrap their head around. They have a hard time figuring out, and they're like, oh, I'll tear an engine apart, but there's no way that I want to do anything electrical. Well, this is going to be Electricity 101. Hopefully it'll help out some people that maybe are a little confused or possibly on the fence about whether they're going to pay someone else to do a project for them. Really, I'll tell you, a lot of times you don't actually have to do that. It's really not honestly rocket science. Elon Musk isn't here, and it's really not a big deal if you just have some simple elementary principles. So I'm going to try to help you along with some of those. So let's talk about wire splicing first. All right, so I'm going to show you something here. Now, a lot of people, this is just a loop, obviously, so it would make little sense that you'd be doing this in reality, but actually, if you just imagine this as two pieces of wire, if you're making a splice, I've seen people do it like this, and then make this big flag kind of thing sticking up. And that is totally wrong. You do not want to do that. And then usually what they do is after that, they take it and they bend it over like this. That's not the proper way to do it. So if you know anything about your history, way back in the day before cell phones and satellite and computers and all those neat things, the basic master of the universe was telegraph, and Western Union was the master of telegraph. They were basically God Emperor Dune. So they came up with what is now still known, about 150, 160 years later, as the Western Union splice. Because, well, if you're running thousands of miles of telegraph line, you got to figure out how to connect things, don't you? So the proper way to do this is actually to take both of these like this. You make an X shape out of it. Don't have them touching the insulation, so leave a little bit of space here. And then just take your fingers and just wrap them in opposite directions. And when you're done doing that, you're going to find out that it takes a little bit of force to pull them apart. Now, they're not super great yet, like I said, it's just wrapped by fingers here, but once you're done with that, as you can see, this is nice even here, and if there's any tug on this wire, the force is still along the axis of the wire. So then, and I'm just using this as a holder, but you probably wouldn't be doing this in reality, but here we go. Handy dandy Weller soldering iron, the soldering machine of choice of, probably 3 or 4 generations by now, I'm betting. I'm just going to go ahead and you're going to solder your connection and make sure that you get some good smoke there, because if you don't have smoke, you're not hot enough. All right, you take a look at that now, and you see that the wire is nicely connected, and now it's actually held together not only by that little twirl that you did with your finger, but now it's actually connected mechanically as well by the solder, which will ensure that it won't pull apart, and also ensures that you have a very good low resistance connection. So after that, you're going to let this sit for a few minutes to cool off. So I'm going to move on to the next one, and then we're going to finish this connection. So the next one, if you're not going to do it that way, you can also use these, which are called butt splices. It's an end-to-end, so that's butt, B-U-T-T. All right, so that would go on. So you pre-strip the wire, and you want that to be about half the depth of what this connector is. So if I can get my finger out of the way here a little bit, you can see now this flared end part has no metal. That is an insulating section. The metal of the barrel is right here in this part. So you want that to go about halfway in, and then you set it. And you can do this two ways. You can use one of these guys with the teeth here, or you can use one of these, which is actually made for these type of crimps. And so you go ahead and get your barrel setting there. And this has a ratcheting tooth. And you give that a real solid squeeze. And yeah, this is good for building wrist strength too. And when it's set, this little tooth pops back again, and the ratchet releases. And then you can turn around and you can see that that's on there pretty good. Now I'm going to show you with the other one. And again, like I said, this would obviously be two wires. You're not actually making a loop. Of course, this is a demonstration, because this would be pointless. Electricity would go nowhere. So you want to look at your jaws here. You've got the point here, and then you've got the anvil. So this could be the hammer, I guess you could say here. All right, so you're just going to lay that in there. Get it situated on the metal barrel correctly. You don't want to be too close to this end, because all you're going to do is mash the wire. And as I was doing that, see, it popped out. You got to be real careful of that too, and make sure that when you're holding it, the wire stays put. And give that baby a good squeeze. And there you are. She's mechanically locked. So there's a couple different ways to do that. All right, so now we're going to come back over to our friend that we worked on a minute ago. And this is called heat shrink tubing. I don't know if you've ever seen it. Some people are going to be very familiar with this. Some people are probably going to be like, wow, I have no idea what that is. Well, this is pretty neat. Watch this. So you're just going to push this over. You're going to take your finger here and kind of feel in the middle to get it centered over the area where the splice is sitting. You're going to set that, and you're going to take a hair dryer or a heat gun, and it doesn't need an absurd amount of heat to do this. And as this heats, you're actually going to see it contract. So this is made out of a specialized plastic material that, instead of expanding with heat, which most objects do, this contracts with heat. So you can now see that it's wrapped itself very tightly around the wire. And inside here is also a melting adhesive, which basically from the heat, as this is also contracting, it's gluing itself to the insulation and also over the spliced area. So you can see in the middle, there's a little bit of a bulge here, right where the wire itself, where I did that solder. So that's, not perfectly smooth as the outside insulation is. And what this will then do is not only protect that from any damage, but keeps water out, so that this will be fine underneath the truck, in the engine bay, whatever areas that are getting splashed. Anything with moisture protects that from corrosion, and you should have no problem there. So that's those two. Come back over here and show you a couple other things. And here we have a couple pieces. All right, and the last couple of things to finish up the video here. So this is what's called a spade terminal. It looks like a little fork here, right? And these go along with these. If you have a barrier terminal block with your screws to be able to attach your wiring to, it just slips underneath it here and you tighten it down. Now, there are also ones that have a full circle here, which is called a ring. Pretty obvious, right? But you do have to remove the screw to install one of those. So if you have connections up underneath of your dash or something of that nature, like the 2 fuse blocks that I have installed in my truck up on the kick panel, these can be your friends, because trying to get those little screws out and then back up there and lined up correctly to go back in the hole, yeah, ask me how I know what kind of a fight that can be. So these are probably better in some circumstances. I would use the rings if they're easy to get to. You know, like if this is just mounted flat here like this, yeah, you'd probably want to use a ring. When it's upside down like this and you can't get to it, it can be a real pain, and you're going to want to use that guy. It just slides right in there like that and tightens up.
Show that again.
Now these do have a particular characteristic. If I can show this to the camera, and hopefully you can see it. If you look in the little tunnel there where the wire goes, you'll notice that at the top here, there's a split. That's because this thing was originally stamped, formed out of a flat piece of metal, and then rolled to make the barrel, and then the plastic piece was installed. So this is something that you need to watch. When you go to put this back in, you go to insert your wire. You want to take this. Now where that split is, so here's your anvil again, the curved saddle side, and then here's your hammer. The point should go towards the rear, and the hammer should be on the side with the cut. If you do it opposite, you're going to split the metal. As this hammer comes in, it's going to take 2 edges like this and drive them downwards, which is not the way you want that to be done. So to be clean with your wiring and to do a nice, proper, professional job, all these little details do matter. And even though no one else may really notice or ever care that you did that, well, you never know. If you're getting ready to do this as a job or something of that nature, someone may actually come and examine your wiring skill and take a look and go, oh, nicely done. He did pick up all those little tiny details. So now you just go ahead and squeeze that down, and you'll see here where the saddle was, it's still nice and well rounded, and the punch where the hammer went on the flat side, which is where the metal is uncut or undisturbed. So that takes care of that. Now, what you want to do here, one more thing to illustrate. So if you happen to be doing these with your push-on connectors, now I don't have anything right here that these actually fit to, but this is a male push-on, so you can kind of get the idea. Obviously, it's pretty obvious how that's working, right? And those two can be connected. Or actually, no, I take that back. Actually, I do have something. Here's a very common relay, which is used for a lot of higher amperage systems, and this just fits right onto there. So now with these, you can crimp, just like I was showing before. Get the wire situated in there, and you get it set just to the right depth. Take and again make sure that you have the hammer side on the correct side. And crimp that on. All right, so now you want to see if you have just a tiny amount of wire hanging out past the end of the barrel. And then, if you really want to be sure that you have a good solid connection and to make sure that it's never going to be any trouble for you, you can actually run some solder down that. Now, here's the trick with these, and ask me how I know. Gravity is sometimes your friend and sometimes it's not. You got to make sure that this is standing up when you go to put the solder in, because these little arms here are actually rolled. They're like little barrels, and the solder will just migrate right up through there. And when you go to try to push this on to the device that you're attaching to, it's never going to go. because this thing's now full of solder and you are jammed. So you make sure that it's standing up like this. You go ahead and very carefully lay in your solder. And if you take a look at that now, you can see the solder. Let me use this for a pointer. You can see the solder is right down in here and went down into the barrel, but did not migrate up the legs. So you'll be able to correctly attach that to whatever unit you're going to use. Now here, after you've done this, I would probably follow that with heat shrink. Just put that from like here right up to here. Again, with your heat gun. And that'll make that joint waterproofed and nice and tight. And it'll protect everything very well. And also protect against stress if this wire has any pulling or action going on like this. If it's connected to something that's moving, you're going to want to have that like from here, say down to here, so you have that reinforced with that heat shrink tubing, which will keep that wire from getting stress cracking right at this junction point. All right, as far as solder itself, and as for soldering, so here's here's where schools diverge. All the solder that you're going to find pretty much mostly in the United States these days is lead-free. It is an amalgamation of other metals, and it doesn't have a very good reputation. Yes, it is avoiding the possibility of lead poisoning through lead vapor. Yes, I get that that is a big problem. This is actually old school. This came from Mexico, where they still use actual lead solder. This is what was in use for about 100 years for making electrical connections. It has a better melting point, it's more malleable, and it's really just more durable. A lot of machinery, chips, sockets, things like that that have been soldered with the newer lead-free years down the line are having issues due to heat cycling. They get hot, they get cold, they get hot, they get cold, the solder cracks. Lead, like I said, everybody knows is pretty toxic. It's not great stuff to be handling or working with, and obviously I'm going to wash my hands when I'm done here, but lead is very malleable. It easily handles those temperature fluctuations and is able to move as other objects expand. So I still use the old school stuff. And you just have your basic electrical tape. Make sure that you get a good quality brand. I usually go with 3M or someone equivalent because they have better adhesive and it just tends to stick and stay in place a lot longer. Wire's wire pretty much. It's electricity flows through it, right? However, you have to watch. There are two types out there now. There's your genuine copper, which is more expensive. I don't know if anybody's ever been watching the price of copper, but it isn't cheap and hasn't been for a while. Then there is copper-clad aluminum, CCA. Now, if you're shopping on eBay or Amazon or something like that, watch what it is that they're describing. You want to be careful with that because it very well may say that it's CCA, and you probably, if you don't know what that is, you're probably not going to pick that up and go, okay, great, I ordered the wire that I needed, and wow, I got a really good price on it too. Now, if you're getting a really good price, be suspicious that it may not be copper. It very well may be clad aluminum. Nothing terribly wrong with it, but it does have a lower tolerance for high amperage circuits, and it doesn't bend as well. It will fatigue and crack eventually. So if it's in an object, like I was saying before, that has something that's moving constantly over and over and over, you may find eventually, especially if it's a larger, heavier type power wire, that you may find that it actually breaks. And that can actually happen inside the insulation, which is really going to drive you crazy then, because you're going to check the ends and everything looks fine, and the wire is actually broken internally, and the only way you're going to find that is with a meter. So I think that pretty much wraps up our 101 here for the day. I might possibly do one later, maybe talking about meters and things like that, a little more advanced on how to troubleshoot circuitry. But like I said, this is just kind of a 101 course, so it was pretty basic. So we go back and look really fast. We had our spade terminal and 0.250 push-on terminal, crimp splice, soldered shrink wrap splice, and we're pretty much done. And just to run down the tools I have here really quick, Harbor Freight heat gun was I think like $9. It doesn't get used that much, so why spend a whole bunch of money on something that might be fancier but is going to do the same exact job? All it does is make heat. It's like a big hair dryer, not fancy. I do like a quality soldering iron. I do like Weller's. They are pretty good. This one has some little headlights in the front, which is pretty neat. That actually illuminates what you're working on. It heats up very quickly, and I've found them to be very reliable. My little go-to cannon here. This guy, I couldn't even tell you exactly where it came from, has been in my toolkit for a long time. This strips wire here, and as I had shown earlier, does the crimping over here. These are pretty much throwaway too. They're about $8, nothing fancy. Good pair of diagonal snips. I would spend some more money on these because right here where the rivet is and the actual parallelism of the teeth, the cheap ones are not going to be very good. And if you're trying to cut a wire, you may find that some of the strands didn't cut cleanly, and that can make a bit of a mess. So instead of spending a bunch of money on this guy, I would actually put more of my cash into one of these and get a good quality brand, whoever you prefer. And then this guy, the ratchet, I'm gonna say I think it was about 20 bucks. This is a T-Con, and this one came from Amazon if I remember correctly. So it's not necessary really to spend a whole ton of money on your tools. I mean, this whole kit in its entirety would probably be less than $100. If you're doing this for a living and it's 8 hours a day, 5 days a week, yeah, you're gonna need good tools. You're gonna wanna spend extra money. You're probably not gonna be using this. Weller's, pretty much you'll find these anywhere. So these are pretty professional grade. Like I said, the rest of it, whatever you feel like spending, it's pretty much all in your ballpark. So I hope this video has been helpful and maybe dispels some of the potential myths, legends, and fears that you might have about wiring. It's not really all that insane or difficult. Give it a try. You possibly could save yourself a lot of money, and some of your friends who are thinking, oh yeah, he doesn't know anything about electricity, nothing at all. You might be able to impress them with what you've completed and be like, wow, hey, nice job. So until next time, FG out.